is a vector? That's right. Previously we had seen that a vector is a quantity that has magnitude as well as direction. For example, let's say an object is displaced from a point A to a point B, which is 3 meters away from it, in a direction 20 degrees east of north. So here, the displacement of the object is a vector quantity. The magnitude of the displacement vector here is 3 meters, and its direction is 20 degrees east of north. As we saw earlier, we can represent a vector by an arrow. So the displacement vector is represented by an arrow with its initial point as A and its terminal point as B. It's denoted like this with an arrow above the letters. Or we can also denote it by a single letter like this. The length of the arrow represents the magnitude of the displacement vector, which is denoted like this. And the direction of the arrowhead represents the direction of the vector. So we see that we can represent a vector in general by an arrow. Now here are a few vectors on the screen with different magnitudes and directions. Notice that these vectors are parallel to each other, while these vectors have a common initial point. Now, obviously a question arises in our mind. Can we compare two vectors? Or when can we say that two vectors are equal to each other? In this video, we will understand this and we'll also look at different types of vectors. First, let's consider these vectors. We can see that they all have a common initial point O. Two or more vectors having the same initial point are called co-initial vectors. So here, vectors OM, ON and OL are all co-initial vectors. Now consider these vectors. Here, they're all parallel to each other, or we can say that they are parallel to this line. If two or more vectors are parallel to the same line, even though they have different magnitudes and directions, they are called collinear vectors. Thus, all these vectors are collinear vectors. Now consider vector AB and vector CD. They both are directed in the same direction and have the same magnitude. So we can say that vector AB is equal to vector CD. Two vectors are said to be equal if they have the same magnitude and direction regardless of the position of the initial points. Notice this important point. It tells us that it's insignificant where the initial points of the vectors are if they're equal to each other. So according to this, we can move a vector parallel to its position without affecting its magnitude and direction. For example, we can make two copies of vector AB by moving it parallelly in this direction or moving it in the same direction like this. Here, all the three vectors will be equal to each other. Such vectors are called free vectors. That is, parallel displacement of vectors gives us equivalent vectors. One advantage of this is that it makes it easier to compare two vectors. Now consider the vectors AB, RS and UV. Let's move them parallel to their positions without affecting their magnitudes and directions such that they originate from a single point. Can you see? Now it's much easier to compare the directions and the magnitudes of these vectors with respect to each other. Now let me ask you a question. What will be the negative of a vector? For example, let's take the vector CD here. We know a vector is defined by two things: its magnitude, that is its strength, and its direction. So the negative of the vector CD is a vector which has the same magnitude as that of CD, and its direction is opposite to that of CD. So vector DC will be the negative of the vector CD, and it's denoted like this. Also notice that vector EF will be the negative of vector CD. Yes, the magnitude of vector EF is the same as that of vector CD, and it's directed in the opposite direction to that of vector CD. So vector EF will be the negative of vector CD. Thus, we saw here when are two vectors equal to each other, and also what's the negative of a vector. Now can you tell me if we can add two vectors? Does this seem possible to you? We will see this in the next lesson. To stay updated and to keep learning such interesting things, do subscribe to our channel. Suppose we have two vectors A and B. Can you tell me if we can add these vectors? What does it even mean to add two vectors? To understand this, let's first look at addition of scalars first. Suppose we have two rods with their respective lengths and mass as this. Can you tell me what will be the sum of the lengths of the two rods? It's easy, right? It will be 3 meters. But now, what if I ask you to add the length of the first rod with the mass of the second rod? Does it make sense? No, right? We know that to add two scalars, they should have the same unit. That is, they should represent the same physical quantity. We can add length with another length only and mass with another mass only, but not a length with a mass. Similarly, to understand what does the addition of two vectors mean, we will have to look at the vector quantity they represent. Let's consider displacement vectors. Suppose we're at this point P and we move to this point Q. We know that this displacement will be given by the vector PQ. Now suppose from point Q we move to the point R here, then this displacement will be given by the vector QR. Now can you tell me what will our net displacement be? Right, it will be from P to R. The net effect of our displacement, first from P to Q and then from Q to R, is equal to the displacement from P to R. And this net displacement will be given by the vector PR. So we can say that the vector sum of these two displacement vectors, PQ and QR, is equal to the displacement vector PR. Now, did you notice these three vectors form a triangle PQR? Yes, the two sides of the triangle PQ and QR represent these two vectors, both in magnitude and direction, which are taken in the same order. That is, from P to Q and then from Q to R. Now, we take the third side of the triangle. Here, instead of taking it in the same order, that is from R to P, we take it in the opposite order, P to R. Then the resultant vector PR will represent the vector sum of the two vectors, both in magnitude and direction. This is known as the triangle law of vector addition. Take a moment and have a look at this. Now by applying this law, we can add any two vectors. Suppose we have to add these two vectors A and B. So for this, first we need to position the two vectors such that the initial point of one vector coincides with the terminal point of the other vector. So we move the vector B parallel to its position without changing its magnitude and direction, and place it such that the initial point of vector B coincides with the terminal point of vector A. Now notice that these 3 points A, B and C form a triangle. So according to the triangle law of vector addition, the vector sum of these two vectors will be the third side of the triangle ABC such that its initial point and that of vector A coincide, and its terminal point and that of vector B coincide. We write it as this. So in this way, by applying the triangle law of vector addition, we can find the vector sum of two vectors. Here we can find the magnitude and the direction of the vector AC by using geometric properties of the triangle ABC. But it's a little difficult. Hence, we will see another easier method for this in our upcoming videos. Here, we just need to understand what does the addition of vectors mean intuitively. Now suppose instead of two vectors, we want to add these four vectors. what will the vector sum be? Can you apply this law here? Right, it will be this vector whose initial point will be the initial point of vector A and its terminal point will be the terminal point of the vector D. How is that so? Suppose first we add these two vectors A and B, then we will get this vector E. Then we add this vector E with the third vector C to get this vector F. Now finally adding this vector F with the fourth one D will give us this vector R. If we think of these vectors as the displacement vectors, then it's easy to see that this vector R will be the final resultant vector of these four vectors. So, we saw here how we can add two vectors using the triangle law. This law is easily understood if we think of the vectors as displacement vectors. Now, instead of this, if we think of the vectors as velocity vectors, we arrive at another law of vector addition called the parallelogram law of vector addition. We will see this law in the next lesson. We will also see how these two laws are equivalent to each other. Imagine a boat is crossing a river from one bank to another. It's moving in the direction perpendicular to the flow of the river. Tell me, will the boat reach the bank at this place P or somewhere to the right of it? That's right. The boat will reach the bank somewhere on the right side of this point P. We know that the motion of the boat is also influenced by the velocity of the river along with the velocity of the boat's engine. So, the boat actually travels with a different velocity, which is the resultant of these two velocities. If vector v1 represents the velocity of the boat's engine and vector v2 represents the velocity of the river, then the boat's velocity v3 will be the vector sum of these two velocities. And what will be this vector v3? Let's find out. Let's say this arrow represents vector v1, the velocity of the boat's engine. We know that the river's velocity is perpendicular to v1. So let this arrow represent the river's velocity v2. Now we know intuitively that the vector v3, which is the boat's actual velocity, will be somewhere in between these two vectors. But how can we find it accurately? Actually, to find the vector v3 precisely, there is a law of vector addition called the parallelogram law of vector addition. Now let's suppose that we have a parallelogram, and the two adjacent sides of it represent the two vectors A and B in magnitude and direction like this. Then the sum of the vectors A and B is represented in magnitude and direction by the diagonal of the parallelogram through their common point. This is known as the parallelogram law of vector addition. Take a moment and have a look at it. Now let's get back to our example. Can you apply this law here to find the boat's actual velocity v3? For this, let's draw a line segment parallel to vector v1 here and similarly a line segment parallel to vector v2 here. So since v1 and v2 are perpendicular to each other, we get a rectangle here. Now, according to the parallelogram law of vector addition, this diagonal will represent the vector v3. We can find the magnitude and the direction of the vector v3 by using the geometric properties of this rectangle. So, in this way, we can apply this law to find the vector sum of two vectors. Now suppose we are given these two vectors C and D whose initial points are not the same. Can you find their vector sum? For this, we will just have to move one of the vectors parallelly without affecting its magnitude and direction such that the initial point of both the vectors coincide. If we move vector D, then we will get this. Now, we draw two lines parallel to vector C and D to form a parallelogram. Then, according to the parallelogram law of vector addition, this diagonal will represent the sum of the vectors C and D. But now wait. In the previous video, we saw that the sum of two vectors is given by the triangle law of vector addition. Here, according to this law, we move vector D such that its initial point coincides with the terminal point like this. So we see that these 3 points, A, B, C, will form a triangle. Now the third side of the triangle in the opposite order than these two represents the vector sum of these two vectors. Thus, we have two laws for vector addition. Which one should we follow to find the vector sum? Actually, both the laws give us the same resultant vector. These two laws are equivalent to each other. We will see this in the next lesson. Here, we saw how to add vectors. In the next lesson, we will also look at how to subtract two vectors. To stay updated and to keep learning such interesting concepts, do subscribe to our channel.